Okay. All right, so we watched that little video last time. But what I wanted to do is let's start off reviewing how DNS works, or what they kind of explained in that video. I'm going to ignore these other two bullet points for a minute, but we're going to look at this. So on the client perspective, on your virtual machines that you install, you have to configure, you have to put in a DNS address, right? Two of them. Should put in two of them. So in essence, what happens here is step one, like if I put in a www.nfl.com, first thing that happens is we're going to go contact our DNS lookup server and see if it has an entry for NFL.com. Well, this is just a very general view. I guess the first thing that happens is not technically that, but we'll look at that in the next slide. But this is the general idea: is our client is configured to go ask one of our DNS servers, and we're going to call them lookup servers, because those are the servers we ask to do lookups for us. I'm going to skip search domains for just a second. So this is the client view. Client goes and asks a lookup server. Great. But on the lookup server, let's analyze what steps actually happen here. So we have, I think I have outlined on the next slide. Step one, client makes a request to the lookup server. Okay. The lookup server then, step two, checks to see if I already have an entry in cache. So if someone has already done a lookup for www.nfl.com, we might have it stored in our local memory, and if we do, we can just send that result back. If we do not have it, we will go on, step three is, if I actually do have it in cache, is it still valid? And DNS, why wouldn't I not want to cache something forever? Yeah, they could change, right? Change the IP address, move different location, whatever. And that's especially true of now a lot of things are in the cloud, and they can move a lot quicker, I guess, with different resources. Okay, so then if it's timed out, or if it's not in the cache, we'll go to step four. Remember on the video we said that, and step four is right there, we've asked the DNS root server. On the video we said there's one place that all lookup servers know how to get to, and that is the root. And the root is the top of our DNS hierarchy. All of our DNS servers know how to get to these set of servers called the root servers. What are we asking? We're going to say, hey, do you know who NFL.com is? www.nfl.com. And they'll say, no, I don't know who it is. But I do know who's in charge of the .com servers. So he'll send back an answer saying, go ask the .com servers. And then our lookup server will go ask the top level domain servers. Do you know who NFL.com is? Or www.nfl.com. They'll say, no, but I do know how you can get to the authoritative servers for the NFL.com. So we'll send them back the address, and our lookup server will then go ask the authoritative servers for NFL.com if they know who www.nfl.com is. And assuming that they do have that entry, they will send it back to our lookup server, who will then cache that and then send the result back to the originating client. So that's kind of what I just said. Store the results in cache and restore the, okay. So, a couple of miscellaneous things are, how did I lock it? We will look at some different timers here. Sorry, it's too noisy on there, so we shouldn't realize it was on. The first one is the TTL, time to live, which basically says how long can this record be cached by any resolver. When we set up our DNS servers, you should be careful about setting this amount, because if you make a mistake in your DNS, you'll have to wait 6 hours or whatever you set the timer to for all the upstream name servers to flush that from their cache. So if you follow the instructions I give you, you'll be good. Anyway, yeah, if we have too high of a value, let's see, did I say that backwards? I think I have those reversed. If we set too high of a value for our TTL, like we set it for 5 days or something, then I might end up with stale cache entries, meaning cache entries that aren't valid anymore. But if I set it too low, like if I set the cache for 5 seconds, then that means they're going to have to go back to the authoritative name server every 5 seconds, and that would be a lot more of DNS traffic that's happening. So I did reverse them. Okay, another topic, or I mean, we just talked about it, this idea of recursive lookups. So back here, this idea of recursion is, I don't know the answer, I'll go ask some, like when we ask him, this idea of recursion is just what I described. Where first we're going to ask the root servers, you say, I don't know, then we're going to go ask the top level domain, I don't know, but here's this, and then we'll finally go ask the authoritative servers for that domain. That's what I call recursive DNS lookup. There are some security considerations with this model, such as, I think they call it a DNS poisoning attack. If I can get this guy to trust my response, or any of these, if I can get this guy to trust a response, an invalid response, we can hijack their traffic or direct their traffic to wherever we want. So there are some security considerations that we just need to keep in mind. Go read about DNS hijacking if you want some more information. Okay, so let's look. So that was the kind of the lookup server view. Now let's go look at, on the authoritative server, what is this process? How does that happen? And I couldn't fit it all in one good slide, but we'll see. Maybe I can do this. Oh yeah. Good. All right. So the message gets to the authoritative name server. The authoritative name server is going to ask the question, am I actually authoritative for this domain? You sent me a request for NFL.com. Am I authoritative for that? If I'm not authoritative, we're going to send back a message to the lookup server saying, hey, what are you contacting me for? I don't know anything about this domain. But if I am authoritative for NFL.com, then I can look and see, do I actually have an answer for that query that you just sent me? If I do, all right, send it back to the lookup server. If I do not have an answer, this next step is, can I delegate, or have I delegated this to a subdomain? So consider this. Consider cs.dixie.edu SSH. Right? Isn't that the name of our machine? SSH. Yeah, cs.dixie.edu. This is the host name. And what's at the end of all of our domains? A dot. We learned that, which represents the root. Okay, so when a DNS query went out here, we go contact the root and say, I don't know, go ask the EDU servers. We go ask the EDU servers and say, I don't know, go ask Dixie. We go ask the Dixie name servers and say, I don't know, go ask CS. Then finally when we get to the CS servers, it checks to see, am I authoritative for this subdomain, cs.dixie.edu. Do I have an entry for SSH? Yes, I do. So I will send that message back. If I can't delegate, or if I haven't delegated it, so for example, what if you went to ssh.chicken, whatever, .dixie.edu. It would go look here, have I delegated to chicken? Nope. So I'll send back an invalid response and back to the lookup server. Okay, so that was, is this kind of review then for 2400 a little bit?
I'm surprised Russ hasn't made a chicken.dixie.edu yet.
I know. It's true. He had a couple of them. Maybe he did. He had like foghorn and leghorn or something. Okay. Let's go back. So, so when the authoritative name server for a domain receives a request for a subdomain's records and responds with NS records, we'll talk about different types of records. For other name servers, that's DNS delegation. Here's an example of this. It still works. Let's look at cs.dns.